talk about disturbing a life. Yo, I. Okay, let's wait for people to come back in because that live was disturbed. Disturbed. I don't know how many people actually just must have been disturbed in that live. I'm sorry about that, guys. I had a bit of a bit of a disturbance there. And I don't know why it seems like I always seem to have someone disturb or something disturb whenever I'm actually explaining something and it's kind of importance. Can you guys just double tap for me in the screen so that we can get the live visibility up with it helps a lot. I think for people that want to kind of join the live lesson, it helps when people have actually they like the live. When you guys like the live, it helps a lot with live visibility. So it's not just for tabs, as you guys know tabs are, but it's just for live visibility, access, and all of that stuff. So guys, we're doing grade 11 2Ds. The reason why we're doing grade 11 2Ds is because it's been a topic in waiting, and there's specific questions that I've been asked with reference to those questions, and it's the learners that I'm actually having a group with that are actually wanting that kind of assistance. So I tend to go where the need is most needed. So hence I'm actually doing this particular lesson with this particular topic. And it's just a pity because I had quite a few people in here, and I'm sure those individuals that were here, who actually was here just a few minutes ago, before I ended the previous live, because I had to end the previous live because of, there was like blowing in some restrictions as well because of so Moody Kid, you were here. Oh man, I think I lost a lot of people actually that were here. Okay. Yeah, that's a pity. Okay. All right, let's just continue. So guys, I was busy basically talking about this particular problem here. And the problem, I'm just going to reiterate again. It says in the diagram, triangle DF is drawn with angle E being 41 degrees, angle F is 63 degrees, and EF is 2,5 units. So we need to find, as it says here, we need to calculate the length of DF. So here is DF. DF is actually the side that we need to find. But as the side that we need to find is DF, I said there's a series of questions we need to ask ourselves when we want to find this unknown side. First and foremost, we are going to ask, where is DF? So here is DF, it's there. Second question is going to ask, in which triangle is DF in? So DF is in triangle DFE. Then we ask, and what type of triangle is this triangle that you have identified, DFE? So we then went ahead, because we didn't have angle D here. We had angle F and angle E, and we want to figure out what type of triangle is this, all right? And we want to check what type of triangle under two categories. We want to establish whether is this a right-angled triangle. And guys, you know what a right-angled triangle, right, is? It's a triangle that has one of its angles being 90 degrees. Or we want to establish, is it a non-right-angled triangle? In other words, there is no angle that is 90. So those are the things we want to establish by asking these questions. So we purely then find the missing angle by adding the angles and equating them to 180 degrees. then we find out that angle D is actually 76 degrees. So that means we have angle D, we know what angle F is, and we know what angle E is, all right? So this is a non-right angle triangle. Now, the minute we establish that it's a non-right angle triangle, that will help us with the next line of thinking. The next line of thinking is, what method or approach can we use to find DF given the information in the triangle? So we are asking ourselves, what method can we use? So for non-right angle triangle, since we established that this is a non-right angle triangle, we can use one of three rules to find missing sides and angles. All right, we can either use the sine rule, all right, which rule I explained just briefly, because we use this formulation of the sine rule to calculate unknown sides. Or we can use this formulation of the sine rule, which we use to calculate unknown angles. Now, it's just convenient to write the sine rule with angles at the top whenever we want to find unknown angles. And convenient as well to write the sine rule with sides at the top in the numerator whenever we want to find unknown sides. And furthermore, we are not going to equate all three of these ratios. We only equate the relevant ratios according to the side or the angle we want to calculate. Only two. Obviously, we use only two of the fractions and we equate those two to find our unknown. Now, there are conditions of use that we need to have in order to use the sine rule. One, we must, from the triangle that we have above, have a side. We must have a side with an angle given. So a side with its opposite angle that is given to us. And furthermore, for what we want to find, either the side or the angle, we must have its opposite side or angle. Okay, and I will explain what I mean by this, but that is the condition of using the sine rule. So if we go back to this problem that I had just looked at now here, we want to calculate the length of DF. We are at the point where we are asking what method or approach can we use to find DF given the information in the triangle. We have DF. It is opposite which angle? 41 degrees. DF, the side, is opposite this angle, 41 degrees. But also given to us is the side, which is 2,5, that's FE, with its angle 76 degrees. 63 degrees, on the other hand, does not have a side given to us. All right? So in your head already, you should be able to see, okay, we want DF. So we are going to write DF in the numerator as a side that we are looking for. On the left at the top, very important. Remember, the sine rule, for sides, we write the unknown at the top. The sides at the top, and we choose two ratios. So the two ratios we are going to be using, look at this, guys. DF over sine of angle E. This would be, generally speaking, DF over sine of angle E. A side opposite a given angle. The side we are looking for over the given angle, the sine of that angle. Equal to what? The side that we have, this is the must-have ratio. We must have a side. Which side? FE. And its given angle that is opposite it. And 76 degrees, which is sine of angle D. Now, I have chosen these two fractions deliberately because this is my givens and this is my given and unknown. So look at my substitution. DF, I want to find, because I want to calculate the length of DF, over sine of angle 41 degrees, which is the angle that is there, equal to 2,5. That's 2,5 over sine of 76 degrees. Sine rule substitution. Then calculation. It's so easy from here. All you simply do is you cross multiply. In other words, we times by sine 41 on both sides to get rid of this sine 41 that's in the denominator. We times by sine 41 on both sides in the numerator to get rid of the sine 41 so that df can be isolated. So that's why I'm saying we just cross multiply. We just say 2,5 times the sine 41 degrees over sine of 76 degrees. We grab our calculator. Can you grab your calculator? There is my calculator. Grab it, put it on first. Go press there for the thingamabob for fraction. Top we say 2,5. We times it, we say times by sine of 41. We close the brackets. We divide at the bottom by sine 76. We close there and we say equally. There is the answer 1,69 and we round off to 2 decimal places. Okay, so the answer is 1,69. Paisley, my calculator has been through hell and back. All right, through hell and back. It has had its time in the sun. And you know what? It is an important feature in my life lessons, so I will not replace it. You know, I love things raw. It is raw. You can see, it's lost its things. It's lost its things. But it's fine, hey? It's fun, hey? Maybe one day I'll be able to purchase one, hey? Nice, hey? We'll see, hey? Alright, there it is, guys. DF is 1,69. Isn't that amazing? Isn't she lovely? 1,69. And we write this word units because when we don't have an SI unit, we obviously use units to represent the length. There it is, DF calculated. Why? Because we went through the process of doing what? Since we were asked to calculate the length of DF, we asked ourselves, where is DF? We found where DF is. Question number 2, in which triangle is DF in? We found that it's a triangle DFE. What type of triangle is it? It is a non-right angle triangle. We established that it's a non-right angle triangle. Therefore, the method and approach, one of the 3 rules. Method and approach, one of the 3 rules. Given the information that we have, we specifically are able to say sine rule. And then sine rule we use, voila. Voila. It is a win. Hallelujah. Hallelujah. Amen. So now we have DF 1,69 units. Who would have thought? Who would have thought? Nice? Nice. Next question. The area of triangle DEF. Now if we look at triangle DEF, we're asking ourselves, we want to calculate the area of this triangle. There are 2 ways to calculate the area of any triangle. The first way, generally speaking, in earlier grades, whenever we would calculate the area of the triangle, we would use a formula called area is equal to half base times perpendicular height. The question is, do we have a perpendicular height here? No. So therefore that formula will not be utilized here. But since this is a non-right angle triangle, it means that our rules can also be used. So what rule can we use here? Well, I have a message for you. We can use, all right, and I established this in our previous live lesson, the area rule. What is the area rule? It is a rule that is utilized for non-right angle triangles to calculate the area. What is the formula? It goes as follows. Area is equal to half the product of the sides. Which sides? Let's look at the sides that we are talking about. The 2 sides that sandwich the included angle. What? The two sides that sandwich the included angle. What is the included angle? The in-between angle of two given sides. The in-between angle of two given sides. In other words, SAS. That's what I usually call it, SAS. Side, angle, side. Hence I say the sandwiches, the two slices of bread that sandwich my polony in the middle. So that is the condition of use. In order to use the area rule, you must have two sides with an included angle. The area rule can be used in situations of that nature. So that's where you can use the area. That is the condition of use. Two sides and an included angle. Guys, it must be the two sides and an included angle. It can't be two sides and then an angle that is outside. No. It can't be. It must be two sides, the included angle. If it was these two sides given to me, it must be this included angle. If it is these two sides given to me, it must be this included angle. The sandwich. Which sand? All right. So if you look at this problem, for instance, then here, if you want to find the area of triangle ABC, look at this. Is this a condition sufficient in the triangle that can allow me to use the area rule? Look at this. AB, what is that? Look at this. AC, look at the sandwich, look at the polony, look at the ham and cheese inside. The SAS, side, angle, side. Oh, this one is it, guys. In the middle, the polony and the cheese, the two slices of bread. Or you can say it's your pizza slice, double deck, extra cheese, mozzarella, and all of everything inside. You see? So this is a condition that warrants us using the area rule. So we can say half of AB times AC, the product of the two sides, times the sine of the included angle. Yes, John Maputla, extra cheese if you want. Then you substitute. Half times 6 times 8 times sine of angle 30 degrees, which is the included angle. Voila! Remember, when you are calculating area, units, square units. We measure area in square units. So now, guys, you've been exposed to the two conditions that we ought to utilize when using the sine rule, the condition that applies when using the area rule. Now let's calculate the area of triangle DEF. Do we have the right conditions to be able to use the area rule in this triangle? And tell me, where is my cheese and polony? In other words, my angle, which one? Which are the two sides? In other words, my extra slices, my two slices of bread, which ones? Who's in between? Who's sandwiched? Which sides and angles would I use here in order to calculate my area? You tell me, you let me know, you expose me so that I can be assisted. Charmaine Diamond says 63 degrees. Okay, so Charmaine Diamond has identified our mozzarella cheese. Thank you so much. Samantha, woo, Samantha. 1,69, very good, Samantha, and 2,5. That is my two slices of bread. So yes, I can make my cheese sandwich, you see. Yeah, let's do this. Let's do it, guys. Thank you, Scully. I really appreciate your nice words there in the comment section. Scully is Scully. Oh, Scully. Oh, thank you so much for those comments. Really appreciate that. Don't know how I did bad in maths. You make this look so simple, Chief. Thank you so much. Really appreciate it. I hope those who are viewing also feel it's simple, because the simplicity leads to excellence in mathematics marks. So we are going to say half area is equal to half the product the product of what? FD, the product, FD times FE times the sine of angle F. All right. So thank you guys. You helped me a lot to identify the two sides and the angle. Okay. So let's go. Half of what's FD? FD is 1,69 times FE 2,5 times sine angle F 63 degrees. After that it's calculator work, guys. It's all calculator work. We just punch in the calculator. Let me grab my calculator. You see, now I'm scared to reveal my calculator. Someone has already said my calculator has been through a lot, and I know, but I just love it too much. So much passion. We've shared so many memories with this calculator. I can't let it go. All right, anyway, so half times 1,69 times 2,5 times sine 63. We close the brackets. We say equal. There it is, guys. 1,88. 1,88. We round off to 2 decimal places. It's standard. 1,88 units squared. We square the units because we know we are dealing with who? Area. Eureka, area. Okay, so what did they say here? They want the area of triangle DF. We've just given it to them. Area of triangle DF is 1,88 units squared. Do we think, guys, we have a good hold over what are the conditions that give us the use of the sine rule? What are the conditions that warrant us using the area rule? We have just in this one single question unpacked when it is that we use the sine rule. Now here we've also unpacked when it is that we use the area rule. We are left with one more rule that we need to unpack so that we know all of the possible situations that prevail in the use. So guys, these are numerical questions. Can I just check with you? We want to find x. Do you guys see where x is? What is x? All right. Okay, so first question we usually ask, whatever we want to find, where is it? Here it is. In which triangle is it? Triangle ABC. What type of triangle is this? Hopefully you guys can see what type of triangle it is. See these questions that I'm asking. Where is he? In which triangle is he? What type of triangle is it? The minute you are able to establish what type of triangle, then we can say approach, method, rule to be used if it's rule, or trig definitions if it's a right angle triangle. If it's a non-right angle triangle, rules. If it's a right angle triangles, definitions. Sine, cos, tan, SOHCAHTOA. So yes, Samantha, this is a non-right angled triangle. You see? Chemdose drugs is like saying, what is this? Chemdose drugs, dollars. Yeah. Guys, your names, they're very scary, some of you. So yes, guys. Okay, so yes, these questions, they help a lot. So then from that, the given information, which rule can we use? Because we've established this is a non-right angle triangle. Which rule? So we go and look what we have. We have this angle, we have this angle. It's always nice if we have the other angle, but of course, that's if it's even necessary, because we don't want to do a calculation that we don't need. So what we can see is that we have a side 8 meters, its opposite a given angle. Ooh, this is giving a sine rule vibes. We have a side that's unknown, we have a given angle. We want the side, so it seems like the sine rule will be applicable. Let's go for it. X over who? Sine of 46 degrees What we want is on the left at the top, at the left at the top, at the left at the top, at the left at the top. Sine of the opposite angle equal to, obviously this side is our givens. So we make sure we have a side, which side? 8 meters. Over who? The angle that we are given, sine of 62 degrees. So now we know, guys, we have a unit. We don't have to now use units. We're going to use meters to actually represent our answer. Cross multiply. Guys, this cross multiplication is so straightforward. So that's why we insist on the unknown being at the top, at the left, top at the left, top at the left, top left, top left, top at the left. No, I don't know. Sometimes I just feel like my vocals just give it away. You know what I mean? So we just multiply them. Just grab our calculator, Mr. Calculator. We've been through so much. We've been through hell and back, my dear. My dear calculator, we've been through it all. Sine 46. We close it up over sine 62. We close it up. We write, bam, the answer for the day. Let's say if we're rounding off to 2 decimal places, can I see if people in the comment section can round off? Let's see what do people have to say. What will be the answer? Round off the answer to 2 decimal places. Let's see if people actually know how to round off. Let's see in the comment section. The answer will be Lou in first place. Seed, God's grace, Girly Mahalo, Samantha. All right. Okay, guys, very good. Please don't let it go, ne? Don't ever let go of the rounding off. I don't want to see rounding off that is funky here. So if all of us can round off, that means forever in the day we'll be able to round off our answers according to whatever decimal place they ask us. You guys are great. Okay, amazing. Right, guys, please, you can do this in your own time. I'm sure you can see, you can screenshot, you can do this in your own time. Please, guys, it's as simple as that. Gelri Mohal is saying, please repeat step number 2. So that means step 1, you are fine, right? Step number 2, Gelri Mohale, we are deliberate in ensuring that when we set up our sine rule equation, the unknown that we are looking for, what we are looking for, we write deliberately at the top, at the left. That is x over sine of 46 degrees, because it's the angle opposite the x. That's why we write it in the denominator. The sine rule gives us that permission. Equal to what? 8 meters over sine of 62 degrees. So the first step is fine, because this triangle meets the condition for the sine rule to be used. We cannot in this diagram use the cosine rule, unfortunately. Okay, we are still going to speak about the cosine rule and its conditions of use. Okay, now the middle step, we have x. It's in the what? In the numerator. We want to get rid of sine 46, which is in the what? Denominator. So algebraically, I want you to understand, my amazing Girly Mohale, that when you want to get rid of something in the denominator, you multiply by that thing, but you do it in the numerator. What does that give you? Power to cancel. But what you do on the left, you must do where? On the right. So that is why you see me in this step having x, because it cancelled, the sine 46 and the sine 46 cancelled. I multiplied by that sine 46 in the numerator so I could cancel the one in the denominator. What I did in the left, I must also do where? On the right. So this 8 meters gets multiplied by sine 46, all of it divided by sine 62. Okay, but what I had said to the learners, you cross multiply. It comes from the understanding that we are multiplying both sides by sine of 46 degrees. Okay, so that's where, for instance, the sine 46, okay, comes from. I hope you understand now. Girly Muhale. And please, Girly Muhale, you must make sure that in the comment section you let me know if still you are saying to me, I do not understand. Please let me know what is it that you don't understand. Okay, Girly Muhale is sorted. All right, guys, what I want you guys to do is find out the rest of these. Let me do this one, because in all of these problems with the sine rule, I've been finding the what? The side. Let's do number 3. Look at this one. What do we have here? We have x, but it is an angle that we need to find this time round. So that means if we need to find an angle, we need to first ask ourselves, where is this angle? It is there. What type of triangle is this angle in? It seems like it's a non-right angle triangle, as you can see. Therefore, since it's a non-right angle triangle, what method or approach can we use? We have the angle, it is opposite a given side. We have another angle, it is opposite an actual side that is given to us. The side 23 is opposite an angle that is given to us. That will help us in setting up for using the sine rule. This will be our second fraction because it will be our givens. This here is unknown at the left at the top, and this one in the denominator. So I go and deliberately choose the sine rule, but the sine rule where the angle is at the top this time round. So remember, this is an angle, this x. So I'm going to say sine of x. Are we together, guys? Why I'm saying that? Sine of x over 43 meters. Now I am using the approach, guys, of not choosing the ratio where the sides are at the numerator. I'm choosing the ratios where the angles are in the numerator. Why? Because Kelly Muhale was asking me, how did I do the second step? I want to simply be able to know cross multiply, because my unknown will be at the top at the left, and then I'm just simply going to what? Cross multiply and then solve. So you see, sine x over 43 meters is equal to, now this is the other angle with its given side, sine 8 degrees over 23 meters. So I repeat, sine x over 43 meters, unknown, known, sine 8 degrees over 23 meters. Good. Sine rule in motion. Then cross multiply. I multiply both sides by 43 meters to get rid of this 43. I multiply by 43 in the numerator, or I can simply say cross multiply. Do you see what I mean, guys? Then we have 43 times sine 8 over 23. Okay, so it's like I am solving for an angle, so be mindful of that. It's like I'm solving for what? For an angle. Very, very important that we note that. So what I'm seeing here is sort of an angle that seems to be obtuse. And you know what, guys? An obtuse angle will be greater than what? It will be greater than 90. And this angle is giving me greater than 90 vibes. So what I'm going to do is I'm going to allow myself to calculate the angles that will satisfy. So let's go here and just simplify what we have there, that 43 times sine 8 over 23, so that we can see what ratio we get. So let's put in our calculator, 43 times sine of 8. We close them brackets, we divide by 23, we get that value here. All right. Now, it's easier to just say x is equal to sine inverse of all of that. And I'll tell you why. Makes life so easy. All right. All right. Makes life so easy. So x is equal to, please take note, guys, x is equal to, now obviously this is my answer. So what I'm going to do is I'm going to say shift, then I'm going to say sine, and then I'm going to click this where answer, because the answer that I just gotten, I want to actually find arc of sine of that answer. Then say equal. Do you see what I get there? 15,08. 15,08. But remember, sine is positive, not in the first quadrant alone, but also in the second quadrant. So what I'm going to do, I'm also going to say x is equal to 180 minus this 15,08. What does that give me? What does that give me? It gives me 164,92. 164,92, because I have two places where sine is positive. And remember guys, what did I say about this angle? This angle is sort of giving me obtuse angle vibes. So what I'm expecting is that this angle will be greater than 90. It won't be 15,08, but it will tend to be 164,92. Okay, so hopefully my grade 11s and grade 12s that are preparing for, grade 12s are preparing for their trial exams, and it's good revision, this is what I'm doing here for the grade 12s, to sort of like be reminded of 2D and the sine rule, area rule, cosine rule, and so forth, because this will be featuring in your paper too. For the grade 11s, they are busy with this as we speak, or at least let me say some of you were busy with this last week at the beginning of the term. Some of you might still feel like, hey, I am still not hot when it comes to this topic. Well, I'm here to make the temperature quite good. Okay, all right. And let me just say, Lou is saying, can you please repeat the obtuse part? Say, Lou, I was looking at this angle. All right, I was looking at this angle. All right, and if this was an acute angled triangle, I'm guessing, let's just do this rather. All right, because that's why in grade 11 we learn about the general solution. So it would be good to find the general solution for this thing, and then after that we can find the specific angles, the possible angles for x. Okay, and we can write them just as possible angles. So if we go back to that place where I said the sine inverse of 43 times sine of 8, okay, over 23 degrees, all right, we would say that is our reference angle. Okay, that's our reference angle. So we'll get a reference angle of 15,08. Okay, and of course, I mean, the decimal will play its role there, but that's our reference angle, right? After getting the arc of sine of this entire thing, we get our reference angle, which is 15,08. Then we'd say x is equal to our sine is positive in two quadrants, the first quadrant and the second quadrant. So what we would do is we'd write this one 15,08 plus k360, right? That's fine. Or we can say x is equal to 180 minus the reference angle, which will give us 164,92 plus the k360. So maybe this will help you a little bit more when I write these two answers as my general solution. But remember that I want specific x values. So what I then do is I substitute 0, all right? In the general solution, in the place of k, I get 15,08. That's a possible solution. If I substitute 0 in this general solution in the place of k, I get 164,92 degrees. So these are possible values of x. But like I said to you guys, I tend to gravitate towards the 164,92. Why? Because when I look at this angle, guys, it looks like an obtuse angle. Say this was a straight line. You see the line here, the angle that it makes is towards the side. All right. So two possible values of x. All right. So I'm just going to leave them there. But I tend to gravitate towards 164,92 because it seems to be a representation of my obtuse angle. Okay. All right. Yeah, you guys can do this one. Okay, this is a typical acute angle triangle number 2. You guys can attempt this one. I'm sure you guys now kind of get an idea. No problem, Lou, you're very welcome. I hope you guys get an idea now of this sine rule and its usage. All right, you can screenshot this and you can do it, guys, please, in your own time. I want to move on to situations that require the cosine rule. Okay, I want to move on to situations that have to do with the cosine rule. And I want to look at the cosine rule, what it is, and then the conditions that apply to the cosine rule. So here we are. You know, when I can, I'm not as consistent as I would like to be, but I am someone who usually goes live. So for the past 2 days, I've been able to, but I'll tell you this, there's days when it's just not possible. Like for instance, tomorrow, I don't think it's gonna fly very well because I have meetings and stuff, so it probably won't fly tomorrow, but maybe the day after that it will, you know? You just need to make sure that you have actually followed me and you are made sure that you press the relevant things that will notify you whenever I go live, so that it flies through your screen, even if, let's say, you are watching your favorite TikTok video or your TikTok channel, and then I fly through your screen and you're like, this guy is live again, might as well join his live and see what he has to deliver this time round. And is it relevant to my grade? That's another thing. Okay, so let's look at this one, cosine rule. The cosine rule is the third rule that we can utilize. You guys have seen me use the sine rule, you've seen me use the area rule, and I've told you the conditions that require the use of those rules. Now, I'm going to look at the cosine rule. What about it? To find the sides and angles in a non-right angle triangle. So once again, non-right angle triangle, we use this rule, the cosine rule. Now, what is this cosine rule? The cosine rule goes in the following way. The square of a particular side is equal to the sum of the square of the other two sides with the difference of the product of the other two sides times 2 times the cos of the angle opposite this side that we began with. Yeah, guys, do you see this? The square of a particular side is equal to the sum of the square of the other two sides. Look at this. The square of a particular side is equal to the sum of the square of the other two sides, meaning c squared plus b squared, minus what? 2 times the product of the other two sides, the b and the c, times the cos of the angle opposite the subject of the side that we started off with. This always is opposite that. This side opposite this angle, this side opposite this angle, this side opposite that angle. It always goes like that. Look at this one. We're just changing letters here, but at the end of the day, it still means the same thing. If we're talking about this side, it means the angle that we are going to actually be cosing is the angle opposite that side, which is cos b. The sum of the square of the other two sides minus the 2 times the product of these two sides. You see? So guys, that's just the cosine rule. It's like that. If we're changing the scenario and looking at c squared this side, then of course, same thing. C squared is equal to the sum of the square of the other two sides minus 2 times the product of the other two sides times cos of the angle opposite the side that we began with. This is the side. This is the angle. This is the side opposite this angle. Okay? Hey, I wonder you guys are hearing me. Conditions of yours. What are the conditions of yours? Okay. If we are given all 3 sides of a triangle, we can use this rule. In other words, side, 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 given. Everyone is given. Obviously, if we are given side, 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 it means we are wanting to find an angle. We are wanting to find an angle. If we are given all 3 sides, it means we are wanting to find the angle, and we are going to only be able to use the cosine rule in order to do that. There's no ways we can use the area rule or use the sine rule. It's only the cosine rule that will work. If you are given 3 sides alone and there's no angle, but you want to find a particular angle, cosine rule will help you. Okay, that's the one condition. Second condition, sus. sandwich. The angle in the middle, sandwich, 2 slices of bread. Okay. Now you will remember that even with the area rule, we used this one. Okay. So that's where there is, but we use this one in order to find not a angle, but to find the side. Remember, with the area rule, we are wanting to find the area. Or if we are given the area, we can find the side using the area rule. So please, guys, take note of that. SAS also helps us to use the cosine rule. 2 sides and an included angle. Guys, if you know the conditions, you will kill. 2Ds will be like a piece of cake for you. You'll be like, why was I even complaining at some point or thinking this thing is hard? It's easy. So let's look at this example. For instance, they say find the length of BC. What do we have here? Isn't this SAS? It looks like SAS, guys. Look at this. It's a side, it's an angle, it's a side, it's an angle, it's a side. It's grade 11, guys. Munya ziwa. It's grade 11. So this is a side, this is an angle, this is a side. So we can use SAS. So that means cosine rule can be used. Trig 2D. Trigonometry 2D for grade 11s and grade 12s. So look at this. What do we say? We want BC. The side we want to find, the subject. So that means we're going to say BC squared is equal to the sum of the square of the other 2 sides. So that means AB squared plus AC squared minus the product of the other 2 sides, AB and AC, times 2, negative 2, right? Times cos of what? Cos of the sandwiched angle. It's the angle opposite the side that I'm looking for. Cos of 130 degrees. Do you want to have an overview view of the thing that I'm speaking about? I repeat one more time. BC squared is equal to AB, one of my slices of bread, plus AB squared, right? You square the AB, plus AC squared, you square the AC, minus 2 times AB, meaning the length of AB, times AC again, times cos of the sandwiched angle. And all you do is use your calculator from there. Okay, and remember, since BC squared is squared, you then have to get to a point. Once you get the value here, you take the square root of that entire value. Yay! So what I usually do, let me just type this in. Okay, guys, I think we need to give my calculator a name. Like, I think it deserves a name. Let's see if people are creative and they can give my calculator a name. All right, so there we have it. You're gonna say 25. What is it? 25 squared, right? Yeah, 25 squared plus 30 squared minus, then I love putting this in brackets, 2 times 25 times 30, close the brackets, times cos of 130. Let's close that one. Stivovo, that's my calculator. Wow. We hereby, from henceforth and forevermore, name you Steve Vovo. All right, I love it, love it. Thank you, as in Zinzi. You are the girl. Okay, so what you have here is that value, but remember, this is BC squared. BC squared is equal to that. I then need to take the what? The square root. So I'm going to say the square root, put answer of what I've just gotten, and then say equal. There it is, guys. That is the value of BC. I take the square root on both sides. BC is equal to 49, if I round up to 2 decimal places, 49,89 what? 89 units. Let's not forget that part. Okay, so that is the use of the cosine rule when I have to find a side. SAS helps me find the unknown side. Okay, the condition is side, angle, side. I need to have two sides with its included angle. If I don't have two sides with its included angle, guys, there's no ways we can use this rule. This rule says I need SAS. SAS is needed by me. Then you'll use me. If not, sorry, cannot use me. Let's look at another example. Look at this one. 50 meters, 30 meters, 59 meters, triangle DEF. Determine the size of angle D. Where is angle D? Let's go and identify angle D. There it is. In which triangle? In triangle DEF. What type of triangle is it? Okay, we would just sort of like assume it's an right angle triangle. Therefore, we are going to use the what? The rule. Because we have S, S, S. And what do we want to find? This angle. And this angle is included between these sides. Are we together, guys? So that when we write the rule, look at the rule, look at the rule. Who are we going to start with? This guy who's opposite the angle we want. So we're going to say EF squared as per the rule of cosine. EF squared is equal to ED squared plus DF squared minus 2 times the ED times the DF times cos of the angle D. You see? Yeah, are we seeing this, guys? Oh man, the silence is deafening. Guys, I don't know. It's either I'm a very good teacher and you guys are like, you don't see the need to comment, nothing. You're like, I feel you, brother. I feel you, I feel you in my bones. I feel you deep down my bones. Or it could be that like you guys are so lost, you just don't even know what question you want to ask. I don't know which one it is. I wouldn't know. All right. So you must let me know in the comment section which one. So you see, this thing goes back to what I said earlier on. To use the cosine rule, the conditions of use are 1. SSS. That's when you want to find an angle. Didn't I say that? Or SAS, when I want to find the side. And I just did a problem now that had SAS. And I found a side that was opposite the included angle. Now I'm busy with SSS and I want to find an angle that is included, and I know the sides that this angle is included in, which means it will be the sum of the square of the other two sides that will feature within my rule. But outside the subject of my rule will be EF squared, because it is opposite the angle. Remember, I said this side opposite the angle. You see, it's like the relationship. Guys, the relationship must be relationshiping. We don't want it's complicated. No, we can't complicate relationships here. In maths, the relationship must work. There's no breakups, there's no nothing here. It's like relationships that work. They need to work. It has to work. So EF squared is equal to ED squared plus DF squared minus 2 times ED times DF times cos of angle D. We substitute. 59 squared is equal to 50 squared plus 30 squared minus 2 times 50 times 30 times cos D. Ooh, now we need to make cos D the subject of the formula. So what do? We transpose 50 squared, negative 50 squared. We transpose 30 squared, negative 30 squared. We can't transpose this because it's negative 2 multiplied by 50 multiplied by 30 multiplied by cos D. So the relationship of this is multiplied to cos D. To get rid of it, we need to divide by it. So when we divide by this entire thing on the left, what we do on the left, which eliminates this, allows us to actually divide on the left hand side and the right as well. So then we can put all of this in our calculator, and this is what we get. Negative 0,027. From our calculator, when say 59 squared minus 50 squared minus 30 squared over negative 2 times 50 times 30, we get this negative sign, negative 0,027. From here, find the reference angle. Firstly, we say cos is what? Negative. Cos is negative. Where is cos? 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 Negative. So cos is negative. Where is cos negative? In the second and the definitely not in the fourth quadrant, can't be. So bye bye. So cos is negative. Cos is negative in the second and the third quadrant. Okay, beautifully said. I love it. So we can then write, if we want, the general solutions first. Okay, we can first write the what? The general solutions. Then from there, writing the general solutions. Okay, or we can do that if we want. But to be honest, guys, if we can find our reference angle, we know that this angle here must be an angle. It can't be greater than 180, because remember, the sum of the angles of a triangle, they add up to 180. So we can't have an angle that is more than 180. Okay, does that make sense, guys? We can't have angles that are more, we can't have an angle that will fit there in angle D that is more than 180. All right. Tando Mahlangu, how did we get the 2 times 50 times 30? Tando Mahlangu, let's go back. Hopefully you understand how we got EF squared. EF squared is equal to ED squared. Calvin, thank you for your compliment there in the comment section. I really appreciate what you've just said there. If our teachers were like this, we would be getting distinctions. Okay, no, you're welcome. EF squared. And by the way, the people that have been joining my live session have been sending me, some people send me messages after they got their June results. Some grade 11, some grade 10, some grade 9, which are primarily the grades that I tend to teach a lot, and I've been teaching a lot in the past 2 terms. Some people have been sending me. One learner in particular from grade 11 said to me, "Sir, I got 100% in June." I was like, "Yo." Term 1, he got 99. This boy, he joined my live lessons he joined my live lessons when I was doing maths in December. We were Decembering with maths here in the platform, and people were doing maths in December, and we were just pushing term 1 syllabus. So you can imagine the kids were running fast in term 1, and they were just doing damage in their respective schools. So many of them sent me a message like, "Sir, you won't believe what I got." I was like, "Yes, great." So I was loving it, totally loving it. It was nice to see the one learner in grade 11 get 100% in June. Can you imagine? Amazing stuff. Amazing stuff. Sekolo! My man. The greatest man in the greatest man in the TikTok space, guys. Have you, do you guys know Sekolo? Sekolo, the amazing TikTok teacher who's doing the most in the platform, like doing the most even in the area where he's currently located, like just doing the best, doing amazing, exceptional stuff. Yeah, that guy is my role model, that's for sure. I look up to him a lot in my platform. Like, this guy is the man. He's the main guy, the main man. All right, sorry guys, got off on a tangent there. Robin Solomon's, we divided, we didn't transpose. I love that. Thank you, Zinzi. Zinzi there in the comment section is doing the work of God. All right, let's see there. So we said EF squared is equal to ED squared. EF squared. Remember, EF squared as our subject length or side, all right, opposite the angle D. So obviously the cos would be of the angle opposite the subject side. So EF squared, then the sum of the square of the other two sides, ED squared plus DF squared, minus 2 times the product of the other two sides, ED times DF. Now EF, 59 squared. ED, 50 squared. There we go. DF, 30 squared. There we go. Minus 2 times ED is 50. DF is 30. Times cos of angle D. Hope we are together there with the substitution. No problems. Now, we transpose 50 squared, additive inverse. 50 squared crosses over Jordan, changes signs to negative 50 squared. Crosses over Jordan, 30 squared, minus 30 squared on the left. Equal to, what are we left with? On the right side, we are left with negative 2 times 50 times 30 times cos of angle D. We want to isolate cos D. Cos D has a relationship with 30 and 50 and negative 2 of multiplication. How do we get rid of something that is multiplied to what we want to isolate? We divide by that thing that we want to get rid of by using what we call the multiplicative inverse, because it is very good, Lou. It's one term. You see, 50 squared and 30 squared we could transpose because 50 squared and 30 squared are separate terms from this single term. This here is one term because it is combined together by the multiply. So we can transpose 50 squared, change the sign, 30 squared, change the sign, but this here, negative 22 times 50 times 30 is multiplied to cos D. So when we are at this point, we can divide both sides by negative 2 times 50 times 30. What we do on the lefty, we do on the righty, or what you do on the righty, we do on the lefty. That's why we have divide by negative 2 times 50 times 30 here on this side. We did that for the left, for the right as well, and that led to the cancellation of the negative 2, the 50, and the 30, isolation of cos D. So cos D is now isolated. Now we can punch this in the calculator. We get what? Negative 0.027. Because remember, cos D is equal to that. That's why I'm saying here, therefore, cos D is equal to that. You see? Now, I just find my reference angle, right? And when I find my reference angle, guys, I know that that is negative. So to accommodate the fact that this is a negative value, I ask myself, where is cos negative? Then I say cos is negative in the second and the third quadrant. Then when I evaluate the arc cos of this 0.027, I take it as a positive 0.027 because I've accommodated the negative sign by asking which quadrant is cos negative, accommodated by identifying the quadrants. Then I evaluate the positive value of 0.027 arc cos of that. So I go to my calculator, let's evaluate what arc cos of that so we can find the reference angle, 0.027. I hope whoever was asking the question about how did I divide by that thing, now you have an understanding. I hope you are clear. I hope you can comment in my comment section and let me know. I understand you, sir. It is very clear, sir. Thank you so much. I really appreciate it. You are the greatest. In the comment section, if you can do that, I'd really appreciate it. Okay, so there we have it. We get 88.45282593. Okay, that's my reference angle. But as I specifically said to you guys, the angle there is supposed to be at least this one, not that one. Because remember, this angle is an angle we need to substitute there inside a triangle. The sum of angles in a triangle is 100, guys, and 80. I can't have a single angle being more than 180. So I'm going to ignore the what? The third quadrant. I'm going to ignore this guy. I'm going to care about the second quadrant. Yes, 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 Lou, it does. Lou, please, I want to marinate and I want to just take note of what Lou has said there. Ask a question. I call the question that Lou has posted there what we refer to as a rhetorical question. My English students will know these types of rhetorical questions. Say that negative from here tells us where cos is negative. Yes, thank you very much. That's why I ask myself, where is cos negative? And I tick in the second and the third quadrant. So that if I'm going to write my general solution, I can say angle D is equal to 180 minus the reference angle 88,452 plus K 360, where K is an element of integers. Then I get that answer of the, let's just say here, 91,55 if you round off to 2 decimal places, plus K 360, where K is an element of integers. I am going to tend to embrace this general solution because it is a good representation of an angle that I want in this quadrant. 91,55 is slightly more than 90 degrees. It's in this quadrant. All right, and it's still within the scope of a triangle, because if I found an angle that's more than 180, problems. So I'm not even gonna bother about the third quadrant. All I want is the first quadrant. Then I'm going to conclude and say, if I substitute in the place of K0, what do I get? Angle D is equal to 91,55 degrees. It's relevant. It's relevant. Lou, you're amazing. You're amazing. Thank you so much for that comment. That comment is very important because, Lou, even when kids are doing general solution questions, this is something that really people, I don't know, it's kind of loses. It's elusive in people's heads that if I say if I'm at this point where cos D is negative, it must register in your head, cos is negative. You ask yourself, where is cos negative? Second and third quadrant. Then you go and say D is equal to 180 minus the reference angle, because the reference angle you found, guys, which is 88, something. Then you can go ahead and say angle D is equal to 180 minus plus K 360 if you want to write the general solution, where K is an element of integers. You write your general solution, and then you can use your general solution to identify the appropriate angle. You are not going to bother yourself with third quadrant. Why? Because you are dealing with an angle in a triangle. So do we all now understand, guys, the two cases where the cosine rule, is utilized? SSS and SAS. All right. So I hope all of you in my live lesson are like, say, using area rule, we know. Can I use area rule here? We know, sir. We know. Can I use the area rule here? Yes. Can I? Yes. Why? SAS. So that means SAS. I can use area rule. I can find the area of this triangle. You know, these are things that we need to know. You know? So when we know these things, guys, then it makes life so easy when we are doing these problems. I just want to now address a question. One learner in one of my groups for grade 11 was asking, he actually threw this question in the group, And I saw people react to the question with heart emojis, but no one actually followed up on the answer to this question. So I want to now address that question, and it will be unfortunate that that particular learner maybe won't be here to see us answer this question. Guys, in as much as we have the problems that have to do with numerical values when it comes to trig 2Ds, there are these questions where we are given variables and unknowns, but they are given as unknowns and we need to write the length in terms of those unknowns. So I want to look at a few scenarios here and hopefully help us to sort of like navigate and deal with problems when they are in such a way. Okay, as you can see, this is a it's a diagram, and we are asked to find the length of BC. In actual fact, for all of these diagrams, we need to find the length of BC in terms of, and we need to find the length in terms of beta alpha A alpha plus beta. We need to write the answer in terms of alpha. Now we are dealing with what you might call Greek alphabet. This is alpha, this is beta, this is A, and then this is alpha plus beta. So we are being asked now to determine the length of BC. Where is BC? There it is. So we need to determine the length of BC in terms of these things. Now, guys, the minute we don't have numerical values or numerical angles and sides, and we are given these variables, we must treat those variables as if they are our given information. All right, and then be able to calculate BC, you having in the answer of BC these unknown variables. That is something I need you guys to really capture with your hearts as I go through this problem. So I'm going to answer this. All right. Charmaine, I might most likely be live again the day after tomorrow. Tomorrow I won't be live because I have meetings tomorrow. But the day after tomorrow, I'll be back. I'll be back. Right? Okay, so let's check out this problem. I want to answer this one and this one so that the learner who was busy struggling with these problems, at least if they have the time, will come to my live lesson. When I've posted the live lesson as a recording onto my YouTube channel, they can check out the lesson there and check it out. So let's go, guys. This is no different from how I approach my other questions. Okay, so what am I asked to determine? BC. So what is the first question to ask? Let's see if you guys have been listening. What is the first question I ask myself? I want someone who's been listening to me well, who's like, say, I know what this guy would ask. I know it. What is the first question I would ask? What is the first question? What is the very first opening question I would ask for this problem? What would I ask? All right, what would I ask? Come on, let's see you guys maneuver in my comment section. Lou, Lou, you are listening. You are listening, and I feel like you are going with me. It's like your destination distinction is where you want to go with me, right? Destination distinction bordering 100%. You want to go there. Let's go there. I invite you to go there. It's a good place to be. All right. I love how you are maneuvering there. Let's go there. All right. So yes, that's the first question. We ask ourselves, where is BC? We are asked to determine the length of BC. So we ask ourselves, where is BC? Ask that question. That's question number one. Where is BC? Where is he? Chini, this is BC. Hey, BC is sitting very nicely there, enjoying. Hey, look at this guy. This guy is having a time of his life. This one. I love BC. BC, I love you. All right. After asking that question, where is BC? Do we see what BC is? I hope we do, guys. BC is here. That's where BC is. What is the next question we ask after asking where is BC? Yeah, let's see. If you guys can answer these questions, then I know you are on point. Where is BC? We asked the first question. We answered the first question. What's the next question that follows that one that we ask? Next question. No, Lou. Before that, there's two other questions we need to ask before we even go to what method. Before we even get to the method. So the first question is, where is BC? So we've located BC. No, guys. No, you guys are getting ahead of yourselves. Okay, no. Okay, before all of that, the second question is, in which triangle is BC? Please, guys, in which triangle is BC? That's the second question. So where is BC? We can see where BC is. Galuk, you need to know where BC is. It would be very painful if someone would say, oh, there is BC. I see BC. Galuk, you need to know where what we are looking for. We need to know where it is. Okay, so that's the first part we start. Second question, in which triangle is BC? Can you guys tell me? Let's answer that question. In which triangle is BC? I'm just going to add a letter here and add D, all right? So that we can have a complete triangle, type thing. In which triangle is BC, guys? Because I want to identify those triangles. D so says BC is in triangle ABC. I love that, D, so good stuff. Triangle ABC. And Zinzi says triangle BCD. Thank you. You guys are amazing. I love you. I love how you guys think. Okay, I love it. Okay, so BC is in triangle BCD. 100% correct. BC is also in which triangle? In triangle ABC. It's amazing that sometimes we can omit to actually think of the triangle. Which triangle? Triangle ABC. How many triangles do we have in this diagram? Okay. Nolo, okay. I'm going live again the day after tomorrow. Not tomorrow, but the day after tomorrow. And it will most likely be at 8 p.m. All right? If not 7 p.m. 8 p.m. or 7 p.m. Just follow and make sure you hit the right notification so that when I do go live, you are notified. Okay? Great. Amazing. Guys, how many triangles? Samantha saying 2, Lou saying 2, Zinzi saying 2, and D's are saying 3. Guys, let's count. Triangle CDB. Triangle ABC. Triangle ACD. How many triangles? 3. We have 3 triangles, guys. We have 3. We have 3 triangles. John Don is like coming here to bother us. The answer is X. You're a funny guy. Goodbye. Okay. Lou. Yeah, that's funny. Yeah. So please, let's know how many triangles we have. All right. So we at least know that BC is available in 2 triangles. Now, what type of triangle, for instance, is triangle ABC? Do you know what type of triangle is triangle ABC? ABC. What type of triangle is it? Do we know? Anyone tell us? Would you mind telling us what type of triangle ABC is? A, B, C. Do you see what's there? What's there? Do you see this? Lou, do you see this? What does this box mean, guys? Right? I hope you understand what this box means. This one is a red. So it's a right angle triangle. Triangle ABC is a right angle triangle. It means I can use the rules. I can use the rules to find. I can use the rules. I definitely can. Okay? I hope you understand. No problem. No problem, Lou. Mistakes do happen. Look at BCD. Triangle BCD. What type of triangle is that? Because you guys said BC is in two triangles. What about triangle BCD? What type of triangle is it? Do you see it? Do we see it, guys? Triangle BCD. Oh yes, very good. It's also a rat. Woo! Right angled triangle. I love you guys. You're amazing. Okay, now, thank you very much, guys. Thank you very much. Thank you. All right. Now, here's the thing. We are given, in the two triangles we've identified, triangle ABC, ABC, right? What we have in triangle ABC, oh, here's another thing. This A here is for the length of AD, okay? Please take note of that. Then, this angle B is in the triangle ADC. The alpha is also in triangle. Is actually this angle A. Okay. Yeah, I hope we are together. Yeah, I think in actual fact, I'm actually not so sure now, because from that sketch or diagram, just hold on a sec. This is gonna go dark. I just want to check. Okay, I'm sorry for the intermission there. I just wanted to verify from the diagram that was given by the learner if this A is actually a representation of the length from A to D, or is this A a representation of the entire length? And I can see from the diagram that was given to them, the length of A must be from A to D. Okay, so with the information that I've been given, I'm hoping you guys can see that if I go to triangle CBD, where BC is, I do not have sufficient information that will help me to be able to find the length of BC in terms of what? In terms of A, alpha, and beta. Why? Because A is limited to just this triangle, because A is the length of AD. So if I'm just going to look at this triangle and say, let me use the information here. Guys, I currently don't have adequate information. All right. So I am going to say, let us pause you for now, my dear triangle. Let's move to the next triangle that is next door to this triangle. What triangle is that? Triangle ADC. Now, in that triangle, I seem to have quite a bit of info. And maybe you are like, do I? Oh, yes, you do. Okay. So let us ask the familiar question. And you know what, guys? When I'm looking at this particular triangle, I'm thinking to myself, if only I can find DC, that is going to help me and assist me to be able to come back to this triangle and find the length of BC in terms of A and alpha and beta. So I'm going to get there eventually. So let's take it one step at a time and go in that direction. Guys, I hope you understand my thinking process here. Before anything, I first asked myself, where is BC? BC is there. Which triangle is BC in? BC is in triangle DBC. It's also in triangle ABC. Maybe someone else is going to be like, so can't we use this entire triangle to find the length of BC in terms of A and everything else? Well, listen to this. If I was to try and do that, I do have an angle for this entire triangle. It's alpha. Does that make sense? I have A, but A is limited because A is from A to D. It's not the entire length from A to B. So my only shortfall of being able to use this entire triangle is that I don't have the complete length of the side AB. So that's where this triangle ABC falls short in assisting me to be able to find the length of BC. So I'm going to hold my horses there for a little while. So that's why I'm saying if I come into this triangle, don't have enough information for the right angle triangle. If I come to this triangle, don't have enough information. So I'm going to come over to this triangle that is here. What type of triangle is triangle ABC? That's what I want to ask now. What type of triangle is triangle ADC? Do we see what type of triangle this looks like? ADC. Does it look right angled? Is it non-right angled? Because the moment you can comment on that, I'll be very swift and quick to actually help us to find DC. It seems like DC is going to be very easy to find. Yes, Samantha, this triangle ADC is non-right angled. And as such, we are going to look at it and be like, okay, as a non-right angled triangle, what method or rule can we use that will assist us to find the length of DC? Do we have information that can help us to find the length of DC? Oh, look at Samantha there in the comment section. Samantha, very quick there. Samantha is like, sine. Do we agree, guys, with Samantha? Do we have enough adequate information to use the sine rule for triangle ADC? So sine rule can be used in triangle ADC. We have an angle alpha. We don't have the side DC which we want. So we have a side opposite a given angle. Good. We have this angle. It is opposite a side that is given. Good. Do we have enough information to use the sine rule for triangle ADC? Okay, Samantha seems to believe so. Zinzi is saying yes as well. Lou is agreeing. Ndiyiso has changed his mind or her mind. Samantha, you are 100% correct. Okay, you were the one that was first on the dial, and I applaud you most heartily and warmly. Okay, grade 11s, and the 12s that are here as well. You are doing phenomenal. So we are going to use the sine rule. And we want the length of who? CD. CD is going to help us so that we can move on back to the triangle CDB, so that we can find BC. You see that the trick behind checking, then moving across, checking, then like, oh, connection, connect back. We are connecting this triangle back to this triangle so that we can find this and then get that. Connections, relationships, right? So let's go. So we are going to say CD over what? CD over sine alpha. CD over sine alpha is equal to what? A over sine beta. Hi guys. Hi guys. It looks like CD is coming up. Oh, isn't this exciting? It's so exciting, guys. Like, I mean, I can't help but just be, wowed when we get to points like this. I'm like, this is so amazing. This is applicable to technical maths. TK, true story here. I actually have a mate who actually does. I think you had asked earlier on about is technical maths something that I do on the live lessons, and the honest answer is that no. But I do have a mate who's part of the Maths Confidence Club. So if you go on TikTok, there is a student of mine. I actually used to teach this guy a few years back in a particular school, in a particular program, roughly a few years back. So the young man now is having what he calls the Maths Confidence Club. You can actually go on TikTok, go to his pages on TikTok, just try and find the Maths Confidence Club. He does run lessons and sessions on technical maths and he's well versed in it. So I would definitely recommend him. Check him out when you do have the chance. It's called the Maths Confidence Club. I think he does also do live lessons. I think he also does virtual lessons via Microsoft Teams, and I think he does actually also do lessons, obviously where you have to pay. But yeah. Okay, CD over sine alpha is equal to A over sine beta. So let's now cross multiply. You see? Cross multiply. And TK, what you can do is you can actually send him a message and be like, I just had a conversation with the host of Maths is a Game. He recommended me to you. I'm doing technical maths. I'd really appreciate joining in some sessions with you. Brilliant guy, amazing. Okay. CD, there it is. Now, those who think simplification can happen further, no, guys. We don't cancel the sine and the sine. We don't do that because the angles are different. We don't do that, guys. Please don't ever do that. We leave it like this. CD in terms of A, sine, alpha, and beta. That is the length in terms of that. I would say we are one step closer. We have just found CD, the length. It is A sine alpha over sine beta. And now, because we have that, all right, remember, we were in triangle ADC. We got CD. Now that we have CD, we go back to triangle in triangle CDB. We are back. Guess who's back? Back again. Guess who's back? We are back. We are back with vengeance. We are back. We are here. We are here. We are back, guys. We are back. And we are back like we never left. So we want now what? The length of CB. So once again, we're going to ask the typical question. What is CB? Where is CB? CB is in triangle CDB. What type of triangle is this? It is a right-angled triangle. So as a right-angled triangle, what are we eligible to use if we have a right-angled triangle? We can use the definitions. Sine, cos, tan. So this here is an angle we are given, alpha plus beta. Makes sense that this is alpha plus beta, because remember, alpha plus beta should give us the exterior angle. This is the exterior angle of this triangle. So when you add the two interior opposite angles, it should give you alpha plus beta. So this makes sense. Makes perfect sense. Okay? Now we'll go into this triangle, use this angle, and find the length of BC. What is this angle? That is, and what is this side in relation to this angle? We call this the You tell me. What is this side in relation to the 90 degrees? We call it the... What relationship exists between these sides given this angle? We call that relationship the... And we use a... So this is the opposite side. This is the... Thank you guys. It is the opposite side. You guys are amazing. Lou and Samantha are like... Lou and Samantha just... They're blowing it off the top. This is the... CD is the... hypotenuse. Very good, Samantha. Lou. Man, Samantha and Lou are just like killing it there in the comment section. Thank you, Tessie. All right, so this is the hypotenuse. The relationship, which trig ratio takes care of opposite and hypotenuse? Which trig ratio? Because we're gonna use that one. Which trig ratio has opposite and hypotenuse? Lou, sine, 100%. Samantha, it's a Lou and Samantha affair there in the comment section. I tell you. So let's go then. We are going to use the sine of this angle. Let's go. The sine of alpha plus beta is equal to my opposite side is CB, or BC if you want. Whether it's CB or BC doesn't really matter. Over what? Over sine alpha over sine of beta. Okay. Hey guys, A sine alpha over sine beta. So this is CB divided by sine alpha over sine beta. Then what do? This is in the denominator. We multiply by it. So we cross multiply. So that means BC is going to be equal to, we cross multiply this. This will be sine alpha plus beta. Okay. Times A sine alpha over sine beta. Okay, so when I conclude, I can then say A sine alpha plus beta over sine of beta. That is BC. So that basically concludes my answer. Okay, so the length of BC is in actual fact A sine alpha plus beta over sine of beta. That would be my answer. Done and dusted. Okay, what looks complicated is actually not that complicated in actual fact. All right, it's just that this is CB over a fraction, but we understand that this is CB divided by the fraction. So we just multiply by what we want to get rid of, left and right. So if we multiply here by sine alpha, A sine alpha over sine beta, it cancels that. We are left with BC alone on the right. But then we multiply by the same thing we multiplied by on the left. That means sine alpha plus beta multiplied by this fraction, A sine alpha over sine beta. So we multiply the numerator. That leaves us with A sine alpha times sine alpha plus beta over sine beta. That is BC. So that's why we conclude and say BC is equal to that. Finished. We can't cancel this sine and this sine because the angles are different. Okay, and as grade 11 learners, we end right there. Nothing more we can do, nothing less we can do, and that's it. Done. So the learner who was struggling with this problem, I've now unpacked it for you by looking at triangle ADC first. All right. But remember, I didn't just look at triangle ADC because I just looked at ADC from the get-go. I first said, where is BC? I then found that in both triangles where BC is, I don't have enough information. So I moved over to this triangle, found out it was non-right angled, used the sine rule to find DC, which connects me back to triangle CBD. Then in this triangle, since this is a right angle triangle, I used a definition, a trig ratio definition, which is sine, so that I can be able to then find BC. And there it is, guys. In terms of A, alpha, and beta, as they had instructed me in the question itself. Okay. Who's feeling lucky? Who's feeling hyper? Who's feeling accomplished? Who's feeling like they have learned like quite a great deal today? All right. I hope you have. Like, I really hope you have. Okay. I really hope you have. So these questions where there are variables and unknown angles, guys, are not difficult. They just need you to think as I have suggested to you. Follow the order and the logic of thought where you ask yourself, where is this thing? In which triangle is it? What type of triangle is that thing? Do I have enough information? If not, I move over to the next triangle. Check it. See if I can connect it back. And then move. Move. You see? Let's check this one. Yes, lovely. I will be posting it up there. All right, after I'm done. Okay. Let's look at this last one. And then, hey guys, I need to also call it a night. I'm sorry that I can't push this and further and further, but I give so that you can be equipped. I don't want to give you guys things. That's why I am suggesting that think through this in this way. You can also have a way out if you think in this way. Once again, what are we being asked to find? The length of BC. Right? Determine the length of BC in terms of x, theta, alpha, beta. Now, I'm sure when you look at the diagram, you're like, oh, this is like, these are the types of problems that I call domino effect. I don't know if you guys know what dominoes is. Do you guys know what dominoes is? It's like where you have like two things standing up, like maybe there would be a pen followed by another pen by another pen, and I'd put this pen slightly tilted towards another pen that's standing upright, and then when I push this pen, it just hits the others, and it has this like domino impact where it's like, poof, we hit that pen, it falls, poof, it falls, poof, it falls, poof, that one falls, and so forth. So I usually call these problems domino effect problems. Okay, and I hope you guys can sort of like glean why I am saying they're domino effect problems. Lou, thank you so much for the comment. I didn't see that. You do an awesome job, so thank you. That's very kind of you. All glory be to the one who created me. Thank you so much. All glory be to God. I do not lightly accept that compliment, except say that it definitely is God's glory that He's allowed me the chance to be able to articulate and also explain things, so that at least there's some sort of like light that descends upon those that do get a chance to hear me share the things that I do share in these live lessons. So let's look at this, guys. We want BC. So our common question, where is BC? Here is BC. In which triangle is BC? In triangle BCE. Do I have enough information in triangle BCE to find BC? No, I don't. So, BC, is it only in this triangle? Yes. What type of triangle is it? Right angle triangle. What rule or what approach or method would I use to find BC if I had adequate information? I would use one of the trig definitions because this is a right-angled triangle. So that means, sorry, we move on to the next triangle. This triangle BFE, do I have information adequate enough to be able to get anything in this triangle? Well, I have one angle, I don't have a side, I don't have anything else. I have that 90 degrees, and unfortunately, I don't have anything more. So I'm going to also abandon this triangle, but it's a right-angle triangle, which means definitions will be assisting. So let's move to the next triangle. Now I am here. What type of triangle is this? All right. It would help me if I would know what type of triangle is this. This type of triangle is also right-angled. Nice. It would be nice if I could find BF, because finding BF will lead me to this triangle. And then finding BE in this triangle will lead me back to my right-angled triangle. Then I can find BC. Do we follow this logical order of thinking here, guys? Are you guys feeling this domino effect, logical order of thought? You know, but I started where? At BC, you know, and I asked questions that led me out here, led me to this triangle, led me out of here into this triangle. Now I am here, and whilst I am here, I'm like, let's go, baby, let's go, baby, let's go. So here we are. So what do we have in this triangle? We have the side AF, which is X. We have the angle, all right? And we can definitely find this side. So what is this side? Where is the side? It's in this triangle. What type of triangle is this? Right-angled triangle. What method can we use to find BF? Because BF will connect me to this triangle, then connect me. You see, I want to be connected back so that I can move from here to here. So what is this? Ha, Samantha. Hi, Samantha, when it's like this is your favorite. Surely this man is like, you are there. Samantha, you are definitely pushing, hey? You know, to me, this is a signal or a sign that you are definitely doing the most in your preparation. You know, I smell great results coming from you. I love your attitude when it comes to, you know, your participation, you know, availability and so forth. Okay, so let's go. BF is the hypotenuse. What about X that we are given? What is it in relation to this angle? Because remember, this is the angle given to us. So we need to always evaluate the sides that are in this triangle in accordance to this angle. So what is this in relation to this angle? Be careful, Samantha. X is not the opposite. Yes, Lou. X is the adjacent. Be very careful. Theta, if we were wanting to identify the opposite, this is the side that is opposite this angle. But theta is next to AF. So we call this the adjacent side. Of course, we know that theta is also next to this side, but this side is typically called the hypotenuse because it is opposite 90. Every side opposite 90 is called the hypotenuse. Okay? Hi guys, I don't know, I hope you are giving me you know, the benefit here of this, you know. I know some of you are like, yeah, this is a nice free lesson, freebies. I know we love freebies, guys. I know we do. Okay. So yes, this is the adjacent, this is the hypotenuse. So which trig ratio will we be using in this situation so that we can find BF? We're going to be using which trig ratio? Give it to me. So I'm going to say in triangle, thank you, Lou, cos. In triangle ABF, cos of what? Of theta is equal to what? X over BF. BF is my connection to this triangle. That is why I'm interested in BF. I wouldn't be interested in finding AB. No. I don't want to waste my time. Imagine being in an exam. It's 3 hours, the exam. You don't want to be wasting time. So please find what is going to assist you for the next and the next step. Are you with me? So BF is what I want to find. So I say cos theta is equal to x over BF. Adjacent side over hypotenuse. Then we want to make x, what do we want to make the subject? BF. But theta and BF, guys, this guy is in the numerator on the left hand side. This guy is in the denominator on the other side. So I usually call this, we play interchange. We interchange. So BF goes into the place of cos. Cos replaces BF. So BF is actually equal to x over cos theta. Interchange. I call this interchange. You want to make BF the subject, it's in the denominator, in the other side for a fraction. It's in the denominator. This cos is on the other side, it is in the numerator. So you can interchange. Cos replaces BF, BF replaces cos. BF is equal to x cos theta. And that's it. That is the length of BF in terms of cos, x, and theta. Okay, so now I have BF. Now I can move from triangle ABF to triangle who? BFE. Let's go. In triangle BFE, please help me now, guys. I now have BF. All right, I want to go find BE. What is BF in relation to this angle alpha that I've been given? Tabang Dlamini, we are doing what we are doing here using the trig ratio because we have a right angle triangle. We mentioned when we began in the lesson at the very beginning that when we have a right angle triangle, we can use so, ka, to, wa. So, ka, to, wa. The sine, if it's sine theta, opposite over hypotenuse. If it's cos, adjacent over hypotenuse. If it's tan, opposite over adjacent. Then you are asking me when we interchange. Okay, guys, let me just show you basically. Okay, remember when you have cos theta is equal to x over BF, what are we trying to do now? We are trying to make BF the subject of the formula. Okay, so let's practically play it out so that you guys can see where this comes from. The interchanging is just a shortcut. Okay, we multiply both sides by what? By BF, don't we? Why are we multiplying by BF? Get rid of the BF in the denominator, and then BF now. BF cos theta is equal to x. Are we together? Okay. Then after that, we divide both sides by BF. Maybe mathematically, let's do it step by step. And when we do that, BF cos theta over cos theta. We divide both sides by cos theta. Let me say that, sorry. Okay, sorry about that step. Remember here, what did I say? I multiplied both sides in the numerator by BF. Why am I doing that? So that BF and BF cancels. I'm left with BF times cos theta is equal to x. All right, but then I want to isolate BF, so I divide both sides by who? By cos. When I do that, I'm left with BF is equal to x over cos theta. Or as Keke Selwyn has said there, okay. Okay, let's just check this out. Keke Selwyn is saying, if you say cos theta over BF, I just want to check what you are saying there. Okay, you are saying multiply by 1 over BF. Okay, so if I do that, that means I'm going to have cos theta over BF. Then I'm going to have x over BF squared. Okay, so I don't know, are you saying multiply by 1 over cos theta from the get-go? Because if that is the case, this is where you are going to find yourself. Okay, which may be a bit more complicated, getting to the answer where you are making BF the subject. Okay, yeah, so yeah, all right. So like I said, personally, I subscribe to the interchange of the two. Okay, but yeah, I would be wary of this. So I mean, algebraically, all right, this you multiply by BF. Okay, that leaves you with BF times cos theta is equal to x, because the BF and the BF cancel. Then you divide both sides by who? By cos, so that you can have BF as the subject. So then the final answer will be BF is equal to x over cos theta. Okay, maybe the longer route, okay, but safe is that. But like I said, shortcut, interchange, guys. And the more shortcuts you have that are accurate, yeah, well, like I said, BF is in the denominator, cos theta is in the numerator, so you can interchange those two. BF replaces cos theta replaces BF. The final answer is BF over is equal to x over cos theta. Okay, now we go to triangle BFE. Hopefully that also answers the other person's question, someone who asked the question. So now we have BF. We can go to this triangle now, triangle BFE. So that's why I said in triangle BFE, my next step, what do I now have? I have alpha, I have the side that is there, and I want to find this side. So what trig ratio can I use? Because this is still a right angle triangle, so it means I can still use trig ratios. Alpha, what is this? This side, we call it what? In relation to this angle, in reference to this angle. What is this side, guys? Do you know? What is BF in relation to this angle? I'm listening. Samzo, very good. It's the opposite side. Then what is this side? Very good, Samzo. What is this side? Thank you, Lou. Thank you, Tabang. Thank you, Samantha. You guys are amazing. What is this side in relation to this angle? What do we call this? So we have an opposite side. I agree. So that's O, opposite side. What is this side in relation to the angle? What do we call this? Be very careful. What do we call this side? Okay, very good. Hypotenuse. Okay, I agree fully, 100%. Tabang as well agrees. So 90 degrees is always opposite the hypotenuse side. So then, what trig ratio involves opposite and the hypotenuse side? Which trig ratio? Because I'm going to now go straight to that trig ratio and utilize it to basically solve for BE. Thank you, Samantha. Samantha. Oh, Samantha is killing it. Samantha, Samzo, Lou. Thank you, guys. Amazing. Okay, just be careful because this is an opposite side. This is a hypotenuse because hypotenuse is always opposite 90. So the only trig ratio that has to do with that, sine is equal to opposite over hypotenuse. Okay, let's be mindful of that. Pythagoras won't help or work here, Tariq. We definitely going to avoid that by all means. Okay, so we are going to say sine of alpha is equal to, remember, BF, we got BF, x over cos theta. I'm going to be very deliberate, right? Very deliberate. Very deliberate. Sine alpha is equal to x over cos theta divided by, what is it divided by? X over cos theta. The hypotenuse, which is what? BE. BE. Okay? So x over cos theta divided by BE. Alright? Then, I want to make BE the subject. So do you want to guess what I'm going to do? Something that I did previously. I'm going to make BE the subject. How? This sine alpha and this BE, I'm going to do what to it? I'm going to play the interchange game again. So I'm going to say BE is equal to x over cos theta, all right, divided. Now, remember, this is x over cos theta divided by sine alpha. So I'm going to say divided by sine alpha, which is the same thing as x over cos theta times 1 over sine alpha, which basically gives me what? X over cos theta sine alpha. BE is that. BE is x over cos theta times sine alpha. On the interchange, no, Senzo, it's not. Okay, Senzo, it's not at all. Okay, on the interchange, BF there is equal to x over cos theta. Remember, Senzo, the explanation of the interchange here is that we want to make BF the subject of the formula, not x. If we wanted to make x, we would cross multiply BF and we'd say cos theta times BF is equal to x. But in this situation, we want to make BF the subject. All right? Yeah. So, I mean, even practically speaking, as I explained, we could multiply both sides by BF. That and that will cancel. Then we are left with what? BF times cos theta is equal to x. Then after that, we divide both sides by the cos because we want to make BF the subject. So BF is equal to x over cos theta. That is the practical step-by-step explanation. The shortcut to it is the interchange. Okay, because we want to make what's in the denominator for the ratio or the fraction the subject. So we simply interchange between cos theta and BF so that we can make that arrangement possible. So BF is equal to x over cos theta. Then in triangle BFE, we said sine what? Alpha is equal to what? X over cos theta, which is BF, over what? BE, which is the hypotenuse. Then what did we do? We interchange between sine alpha and BE. All right? So that's why we have BE is equal to x over cos theta. I know I'm going to be dividing by sine alpha, but I just write divided by sine alpha. Change the divide to multiply, and you know what happens to a number or a fraction when there's division. You can change the divide to multiply, then we can write this as a reciprocal or the inverse 1 over sine alpha. Then we do the multiplication. X times 1 is x, cos theta times sine alpha is cos theta times sine alpha. That is BE. We are close to the finish. We now know what BE is. Now we can come to triangle what? BCE. Lou, love it. I love that term. Flip it. Reciprocal. We flip, change divide to multiply, flip. Sine over 1 becomes 1 over sine. I love it. I love it, Lou. Lou. Okay? Go, Lou. So now we have BE. Now we can go and say in triangle. And guys, I love this idea, this notion of whenever you're working in a particular place, you write down the triangle. You know, what logical order must come when a teacher is seeing you writing down in triangle ABF, he sees your work. In triangle BFE, sees your work. Triangle BCE, conclusion. It's like introduction, body, conclusion. It's like you're writing an essay and it's brilliantly written. The wording is amazing. Yeah. Okay, so now we are here. Triangle BCE. What do we want to do there? We want to calculate. Remember, our whole goal was to find what? The length of BC in terms of that x, theta, and alpha. So we've come a long way. We've been collecting. Now we have BE, and BE has collected x, has alpha, has theta. I think we are ready now to take beta and finish it off so that we have the length of BC. So if we look at beta, what is this side in relation to this angle? Because we have a right angle triangle, and we know that in a right angle triangle we use the trig ratio. So what is this BC in relation to this angle beta? What is this BC? Anyone? Anyone? Thank you, Lou. Thank you, Samantha. I tells you are making me cry. Kuhle. Oh, you guys are already answering the next question. Okay, no problem. All right. So like I said, guys, you guys are already answering everything else. Kutle is like running ahead, like, I don't have time for this. Asking me what this side is. Asking me then what this side is. I will tell you what the trig ratio is. Okay, guys, please take note. I understand. Kutle, I understand. You even have a very vicious dog that is, very much, it's like looking at me like ready to kill, to destroy. So angle B, this BC is the opposite side. And then this BE, which we had just found, is the hypotenuse. So what trig ratio exists with the relationship of opposite and hypotenuse? Kutle said it, 100% correct. It is sine theta. Guys, as long as, guys, we are seeing what we are seeing, I can see people who are rushing and telling me the answer, but as long as we can identify trig ratio. So we are going to say sine of angle beta is equal to what? BC over what? X over cos theta sine alpha. What do we want now? We want BC as the subject. Where is this all? It is in the denominator. So what are we going to do? We are going to cross multiply. No interchanging, but cross multiply. We multiply by what's in the denominator on the left and the right. So that means sine beta, which is this guy. We cross multiply. We multiply by x over cos theta sine alpha. That's equal to what? BC. Therefore, we can conclude and say BC is equal to x sine beta over cos theta sine alpha. And that is it. So that is the two questions that young person that posted in my group wanted clarity on. So whether we are dealing with explicit numerical value type questions where trig 2Ds are concerned, or we are dealing with variable type questions where trig 2Ds are concerned, our method and our approach is always going to be, where is this side? What triangle is there that's located? What type of triangle? Okay. And then from understanding if it's a right angle triangle, we know SOHCAHTOA can be used. But if we understand that it is a non-right angle triangle, then we know that we ought to use the rules. Right? And that is the point. We always move from the triangle with the most information to the triangle with the least information. and we try and connect the what? We try and make connections with the sides with the most information so that it can lead us to the triangles with the least information so that we can ultimately find that particular thing that we have been asked to find initially. So Lou, we don't have to use but the reality is that in most of these questions, right angle triangles will suggest that we use the what? We use the trig ratios, especially when you have the angles. Remember, Pythagoras is used whenever you have two sides and a missing side in a right angle triangle. You can use Pythagoras to find an unknown side. But in most cases, guys, with sides and angles, we just maneuver with the trig ratios. Now, for all those people that just joined in because you came in at the time that you did, unfortunately, I am actually shipping out. Right? Yeah, I cannot pull another few minutes extra because I've been here, guys. You guys have been generous and amazing hosts. All right, because you will know, those who joined in early, that we have been in this thing since just before 9 o'clock, and now it is 17 minutes past 11. That's a lot of time. Okay, and I do not mean to be one who says anything, but remember, guys, this is a free offering and a helping hand. Okay, yeah. So you guys need to take the skills that you have seen me utilize doing these problems. More than anything else, take the skills, utilize them to then be able to answer questions. All right. I see there's someone here in the comment section that says, can you show me one or help me with the area rule? So I'll just do one problem that has area rule, but those who have been here will know I spoke about the conditions that relate to the area rule, and you guys, I hope you remember very well, I said that we use the area rule whenever we have what condition? When we have sus, okay, sus, in other words, two sides with an included angle. When we have a situation when we have two sides and an included angle, we can use the area rule because the two sides will represent the product of the two sides. We need to multiply it times the half times sine of the included angle. Okay, so that's that. I just wanted to show you one problem where obviously area rule will be used. Remember, if it would say here, determine the area of triangle ABC. This is triangle ABC. Now, what did I say are the conditions to use the area rule? If we are given, okay, if we are given, who is this guy, Troy? Just be mindful of the lingo, my man. Yeah, I wouldn't want to expel you from my class, you know. Determine the area of triangle ABC. So we have triangle ABC there, right? And this angle here is what we refer to as the included angle, whereas these two sides are my sides that are sandwiching. You know, sandwich in between the two sides is this included angle. So those are conditions that warrant me using the sine rule, because I have an angle that's included with two sides that are adjacent. The two adjacent sides that are actually given to me are the two sides I need to use to substitute into the area rule. What's the area rule? The area rule simply states that half of the product of the two adjacent sides, which in this case would be AB times AC, times sine of the angle. Which angle? The angle that is sandwiched in between, or in other words, the included angle. So what is the two sides that are adjacent? It's 23. So I'm soon going to halves times 23 times the 30. And then we say sine of angle 50 degrees. And then guys, it's your calculator from there and the answer. Okay, so if you're asking me use of the area rule, we use the area rule when there's two adjacent sides with its included angle. Of course, using these two adjacent sides, you would need this included angle, which we don't have. So we can't use this side and put in this angle. No, we can't. It must be this side and this side with the included angle that warrants us using the what? The area rule. Okay? And the area rule, like I said, is half the product of the two adjacent sides times sine of the angle that is included. Okay, Sam was asking, why are we using sine? Because it is part of the formula for the area rule. The area rule has sine in it. What must we write there? What do you know? Sam's of 16. What grade are you in, Sam's of? Because there's lots of questions you're asking there. All right. One would hope that people are being taught in their respective schools. You guys are coming to ask me, especially if you are in high school, you are in grade 11, you are currently being taught this content now as we speak. You know, you'd have to have a clarity in the usage of the respective formulas as it relates to the conditions that are present in a diagram. So that's why I'm saying for this diagram, we can use the area rule because the conditions, two sides and an included angle, they are there. Okay, right, that basically, this is how the cookie crumbles, and that's me calling it a night. A few of these people seem like trolls. TJ, for real, hopefully you're not a troll yourself. We were just introduced to the work today and I was not paying attention, sorry sir. Samzo, that exactly is the reason why you need to pay attention. These live lessons cannot be the avenue where you want to first pay attention. These live lessons have to be, they need to supplement what is already being done in your classroom so that you can benefit that much more as you actually now, you know, have these same concepts re-emphasized in your mind and heart, and they become easier as you hear someone else different from your teacher explain the very same concepts. Then you can see that maths has integrity, whether it's being explained by me or being explained by your teacher. It has nothing to do with anything else than the integrity of the content that you are covering. Guys, let me love and leave you. Thank you so much. It was really good having you. Hopefully, Senzo, you've put this in your calculator, you found the answer, you know what the answer is. And remember, since it's area, you make sure that you write square units for your answer as well. I love you, love you, love you. I've never loved strangers quite the way that I do. And remember, this is a sacrifice of my time, availing myself in this fashion, really trying to explain simplistic concepts in maths. Hopefully it adds value to you. I know most of you are doing the most. You are preparing yourselves adequately. Some of you really want to change the dynamics of your path, career path, and that is why you are investing time going or doing the maths so that you can have choices that are different. As a grade 11 learner, if you're a grade 11 learner, you guys in a few months' time will be writing your final grade 11 exams. And I cannot re-emphasize how important your end of year grade 11 report is. It needs to be a quality report. You owe it to yourself to ensure that you do the most as a grade 11 learner to make sure that you have a report. So whereby next year when you apply to the different institutions and you are wanting to have a place in an institution of your choice, you can have that report to actually, you know, begin that journey for you, so that next year you can confirm and solidify your place in that institution where you want to go to and do the course of your dreams and actually live the dream of your life. You know, I see various young people on various social media platforms. I know of a few. Some of them I've had some personal one-on-one interaction, having been an educator for the period that I have. And there are people that are like, for instance, there's like a social media person here on TikTok called Dam Dizo. He is a medical doctor and he just finished his studies. That's someone I knew personally. Well, Dam Dizo on TikTok. Very inspirational, the young man. Finished his MPCHB degree at University of Cape Town. That's a young man that I've had the chance of being able to, teach at, or let me say, interact with at some point. And also, he's really doing the most, So what I'm saying is that if you have a dream and there is a vision for your life, and you feel like doing the maths will sort of like change the dynamics for you, then please, guys, don't. Every worthwhile sacrifice is going to be worth it. You can change the face of I guess the outlook of your own personal life through maths education and ultimately the choice of career path and so forth. And I know some of you are on that journey, and you'll be doing the most come end of this year. So let's continue practicing the maths. Let's continue doing what we need to do. Maths is just as much as like someone who is training, who's wanting to develop muscle and become strong, become healthy. You need to actually do things that will lead to that on a daily basis. You can't skip a day, because if you do, you lose your momentum, and even the things that you think you were good at. You could have been good at something like maybe 2 months ago, but I promise you, if you're out of practice, you can be very poor at it again. So you need to have consistency in practicing the mathematics so that you can develop that maths muscle. You can develop your eye for many other concepts that are in mathematics so that you can actually perform well. So guys, with that said, much love to you, and thank you so much for joining in. It was really great. Thank you for being so interactive as well. Thank you, Samantha. Samantha, you are a star. Like, you're a star. Lou is amazing. Keke. So you come in there like a pro, sort of like obviously midway through the lesson, and actually just contribute a storm. You guys are amazing, amazing, amazing. Calvin, thank you so much for your generous comment, especially as well. Like, that really meant a lot. Like, you guys don't know how much some of your comments, especially the positive ones, how they really affect me positively in so far as ensuring that I do come back again and again to sort of like do this as that free helping hand to you guys. Precious, thank you so much. It's official, I'm sure that was good. Kiano Adams, J, Mohammed Square, Cindy T, Busasa Teo, we've got Pela, we've got Mpo, Umaki, we've got Mamela, we've got Ompi, Sifisile Sangweni, Linda, we've got Cass Rap, Lee, Riley, Lil Max, Bradley Kubega, Talita, Radiohead Lover, Tembi Sobachana, CD, Funny, we've got Uvira, we've got Kentmore, Oyena Ovai, we've got Uncle Regal, we've got DFG, got Defela Mohotsi, we've got Master T, we've got Presh Mohale, we've got User 299, you've got a long way there, Arieta P-Boy, we've got MT Marvin, Puleng M, Rafnati, we've got Sicelo Impilo Mchali, Mbali Mbele, we've got Kuso, we've got Scooter, the tutor. Got people that are actually tutors here that come in the live, and honestly sometimes I do not accept tutors to like come through. I've had some good positive experience with certain tutors coming through into my live lessons, but I've also had negative experiences, and it is not something that I tend to do, especially if I see them request. I just see them, I watch them, and I'm like, no, I'm not going to accept the request, because it's just that depending on the person who does come on, some do tend to display a level of arrogance which I don't particularly like, and some people just, I don't know, they just want to come and show a face, or maybe use the platform to advertise and so forth. Maybe I can actually allow that at some point, but for now, guys, I'm also trying to just sort of like authentically do what I'm doing without having to compare myself with anyone, because that's not the point. The point is to just help those who want help with maths. User 577, amazing. Ndombi, hello, Simpiwe Kani, and Nke O Matebula. All of you guys, thank you so much for joining in the live lesson. And thank you. See you again next time. when we do meet. Like I said, tomorrow I might not be here. Day after tomorrow, might see you again. Thank you so much. Samantha, thank you. Have a great night and much love. Bye. I wonder if we will ever have subscribers. I wonder if subscribers will ever be a reality in this life. Let's see. Oh wow, so I do have one subscriber. I do. I actually have a subscriber. One. Oh wow. I didn't know. Tell you things I didn't know. Kinakatlejo. 19th April 2025. So someone actually does subscribe to this channel. That's cool. That is nice. Oh, bot. I love that. Okay, guess there's things I didn't know that I now know. Okay. Alright, guys. Yeah, let me love and leave you. Let me just end this.